All right, today we're looking at improper integrals, which are definite integrals which in some way are different than what we're used to seeing. So, let's look. So these are the types of improper integrals. They're functions which are not continuous, functions which are infinite at one or more points. So like this first one here is infinite when you plug in 0 because it does not exist in the domain. This one is infinite at 3. This one is infinite at 2 and -2. So we have different forms of where they're infinite, but the idea is just if the x in the interval doesn't exist in the domain. And the last one is when you have an endpoint of plus or minus infinity. Now the idea here is we're going to be turning these integrals into limits. All right, so here we have our improper part being the 0 in the bound. So what we're going to do is we're going to change it, limit as a approaches 0 from the right, integral from a to 1, and then I'm going to go ahead and change this to x to the -1/3 dx. Now we're just going to integrate. Integral of x to the -1/3 is going to be x to the 2/3, and then 3 over 2. 3 over 2, there we go. From a to 1. And now we'll plug in the upper and lower bound like normal. Limit as a approaches 0 from the right of 3 over 2 minus 3 over 2 a to the 2/3. And at this point, it becomes just a limit problem. So limit as a approaches 0 from the right, that's going to be 0 here. And so we just are left with 3/2. So this integral is equal to 3/2. There's not much more to say to it than that. You're just replacing it. The only other thing we're going to look at are ones where the part that is improper is inside the interval. So from 0 to 9, neither of the bounds are an issue, but you can't plug in 1 here. You end up with a 0 in the denominator, so that doesn't work. That means it is improper, but it's improper at 1. So we need to split up the integral. We're going to do the integral from 1 to 9, and we're going to replace this 1 with a. Limit as a approaches 1 from the right. 1 over x minus 1 to the 2/3 dx. Man, that is not one to write. All right. Plus, and then the limit as b approaches 1 from the left, and we'll do the integral from 0 to b of 1 over x minus 1 to the 2/3 dx. Okay, and that's what we're going to integrate with and integrate and have. So we have limit as a approaches 1 from the right, and this is going to be x to the minus 1 to the 1/3 divided by 1/3, so that's 3 a to 9, plus the limit as b approaches 1 from the left of 3x minus 1 to the 1/3 from 0 to b. And we'll do both of these limits. Now, one thing we didn't see, and we'll see in the next problem, is that if it goes to infinity, like if the limit is not finite, in those cases we say it diverges. And in one of these where we have to split it, if even one of these limits is equal to infinity, then the whole thing diverges. So let's look at this one. Limit as a approaches 1 from the right of 3 times 9 minus 1 is 8. 8 to the 1/3 is 2. Minus 3 times a minus 1 to the 1/3. 3 times 2 is 6 minus, all right, we can plug in this 1 here and it's not an issue, so we have just 0, and that gives us 6, plus, and then limit as b approaches 1 from the left of 3 times b minus 1 to the 1/3, minus, plug in 0, that's -1 to the 1/3 is -1, and then times 3 is -3, so plus 3. And then we'll approach 1 from the left. That just gives us 0, so that becomes 0 plus 3, which is 3. 6 plus 3 ends up giving us 9. Okay? So that's that one. Now let's look at one that is infinite. Let's look at this one right here. If we do this one, integral from -1 to 0, 0 is the improper part, so limit as b approaches 0 from the left, integral from -1 to b of x to the -3 dx. Integral of x to the negative 3 is x to the negative 2 divided by negative 2, from negative 1 to b. Plug in the upper and lower bound. We have negative 1 over 2b squared minus negative 1 over 2. And so that becomes plus 1/2. But this time, if we go to try and plug in 0, we end up getting 0 in the denominator. And so we use our old limit techniques to figure out what this goes to. If we look, we have a negative 1 on top, and we're approaching 0 from the left, so it's negative really small numbers being squared, which becomes a positive really small number, which means we have negative over a positive really small number. That's going to give us a negative infinity. Now, it's nice to be able to find which infinity we go to. That's a great review, as we're always doing. But you don't need it for your answer. Your answer would just be, hey, since this goes to infinity, it diverges. This integral diverges. All right, if you have any more questions, please let me know. You'll have a great day.